continuing to work with the implicit equation that we had before, 4y squared minus x squared plus 2x equals 2, we found before that the derivative dy dx is equal to x minus 1 all over 4y. And so we can utilize this information to answer some different types of questions. And so this first type of question is find all points on the graph with an x-coordinate given. So this one, it is x equals 3. And then find the slope of the tangent line at those points. So we have x equals 3 given, and since this implicit equation doesn't necessarily define a function, one x value doesn't necessarily pair up with a single y value at most. It can have more than one y value paired up, and we'll see that there's actually two for this particular example. So the first step of this problem is to just do some algebra. The second step, when we're finding the slope of the tangent line at those points, that's when the calculus will come into play. So we'll have to utilize the concept that slope of the tangent line is the derivative. So first, the algebra. We have x equals 3 dictated to us, and so we just want to plug that in for the x values and figure out what y values would go with it to pair up for an ordered pair. So we have 4y squared minus, and we plug in the 3, so we have 3 squared. Plus 2 times 3 is equal to 2. I've plugged in 3 everywhere there was an x for my implicit equation, and now we just need to do some algebra to figure out what the y's are. So we have the 4y squared. Minus the 3 squared would be minus 9, so we have minus 9, and then plus 2 times 3 would be plus 6 equals 2. So we have a minus 9 plus a 6 on one side. So that would be 4y squared minus 3 on the left-hand side equals 2. So we can add 3 to both sides. And we have now just the only term that involves y on the left-hand side, 4y squared, is equal to 5. Divide both sides by 4 to get y squared by itself. And we have 5 over 4. And then we get y by itself by undoing the square. Well, to undo the square, we need to take the square root. But see, that square was hiding information about signs. The thing that would be squared, whether it's positive or negative, we lose the information about the sign by squaring it when we're staying with the real numbers here. So we take the square root, but we have to have the added caveat that we could have plus or minus the square root. So we have plus or minus the square root of root 5 over 4. Now we can use exponent rules, which are really the same as our square root rules because we understand the square root is the power 1/2. So we can take the square root of the top over the square root of the bottom using these exponent rules. And 4 is a perfect square, so we can clean this up just a little bit here. And we have the y values of plus or minus root 5 over 2. And so overall then we've got the points. Each time we started with an x equals 3, and we got two different y values. We have the positive root 5 over 2 and the negative root 5 over 2. And so those 2 points are the 2 points on the graph of this curve that have x value x equal to 3. So we've done the algebra at this point, and now we're ready for the calculus. We want to find the slope of the tangent line at those 2 points, so we're really wanting to evaluate the derivative at those 2 points. This is slightly different than evaluating a derivative when all we have to work with is x, but it's not a whole lot different. We're still working with the derivative function. It's not really a function. The derivative, we'll say, the derivative equation that has both x and y in it. And we use this bar notation for evaluation. So first we will evaluate it at the point 3 root 5 over 2. Okay, that's the first point we'll be working with. And so we take this derivative equation, and everywhere we see an x, we plug in 3. So you have 3 minus 1 on the top. And everywhere we see a y, we plug in the root 5 over 2. So we see that happening on the bottom. So then we've got 3 minus 1, which is 2 on the top. And the bottom we can simplify. We've got a 4 times root 5 over 2. So there's a factor of 2 there on the very bottom that can reduce out with the 4, leaving us 2 root 5 on the bottom. Of course, that can be simplified a bit more. There's a common factor of 2 in the top and the bottom, leaving us with an answer of 1 over root 5. Now, that's not rationalized. It has a root in the denominator, so we could rationalize this by multiplying top and bottom by root 5. That's just a fancy form of 1. And so now that would leave root 5 on the top with 5 on the bottom. So that would be the slope of the tangent line to the curve at the point 3, root 5 over 2. Now, the arithmetic that we would have to do to evaluate the second point is going to be identical. The only thing we have is an extra negative sign floating around there. So we have dy dx evaluated at 3, and this time negative root 5 over 2 is going to look much the same. We've got the 3 minus 1 on the top, and we've got the 4 times, this time negative, root 5 over 2 on the bottom. And what'll play out is all this algebra will be exactly the same, except with a negative floating around, so we will get a negative root 5 over 5 as our slope of the line tangent to the curve at the point 3, negative root 5 over 2.